All right, let's talk about machine learning. It's one of those terms that sounds super complicated, but it doesn't have to be. Really, the whole point of this explainer is to cut through the noise and give you a simple guide. We're going to figure out how to look at any problem and know exactly which machine learning tool is the right one for the job. Let's dive in.
So think about it. You've got a goal. Maybe you want to predict house prices, or maybe you're tired of sorting your vacation photos by hand. Or hey, maybe you're trying to figure out if your customers fall into different groups. All of these are classic machine learning problems, but they all need a different approach. So how in the world do you choose the right tool? Well, that's exactly what we're here to figure out.
Okay, the first and biggest decision you have to make has nothing to do with fancy algorithms. It's all about your data. And the question is simple. Do you have an answer key? So if your data already has the correct answers included, we call those labels, then you're doing something called supervised learning. But if you've just got a big pile of data with no answers attached, no labels, then you're heading into the world of unsupervised learning. That's it. That's the first fork in the road.
So let's go down that first path. Let's say you do have an answer key. Your data is all neat and tidy with the correct outcomes already there. This is what we call supervised learning, and the name makes perfect sense. You're basically supervising the computer by showing it what the right answers look like so it can learn the rules.
All right, so we've decided we're in the supervised learning world. Now there's another question we have to ask. Take a look at your answer key. What does the answer actually look like? Are you trying to predict a specific number, like a price or a temperature? Or are you trying to sort something into a group, like yes or no, or maybe cat, dog, or fish? This one little detail sends us down two totally different paths. So if your goal, your answer key, is all about predicting a number, welcome to the world of regression. All you really need to remember about regression is that it's for predicting a specific numeric value. You're not trying to put something in a box. You're trying to land on a number. How much? How many? How hot? It's basically like having your own personal crystal ball for numbers. So, when would you actually use this? Well, let's say you want to predict how many ice creams you're going to sell on a super hot day. That's a regression problem. Or trying to figure out the perfect selling price for a house based on its size and location. Yep, that's regression too. You're just finding the patterns between things to predict a final number. But what if you're not trying to predict a number? What if your answer key is all about labels and groups? For that, we need a totally different tool from our toolkit. And that tool's job is classification. Classification is pretty much what it sounds like. It's all about sorting things into groups or classes that you already know exist. You show the computer a bunch of examples. This is a cat, this is a dog, and it learns the patterns. It basically becomes a super smart sorting hat that can look at something new and put it in the right bucket. Now, even within classification, there's one more little choice. How many buckets are you sorting into? If it's a simple this or that question, like A or B, that's called binary classification. But if you have a whole bunch of options to choose from, like A, B, C, or D, then you're doing multi-classification. And you see binary classification everywhere. Anytime there's a yes or no question, this is your tool. Is this email spam or not spam? Will a customer buy this product or not? Is this transaction fraudulent or is it legitimate? It's the ultimate decider for any two-option problem. And of course, when you've got more than two choices on the table, you're using multiclass classification. Think about a photo of a penguin. Is it an Adelie, a Gentoo, or a chinstrap? Or when Netflix recommends a movie, is it a comedy, a horror, or a romance? The model has to pick just one correct label from a whole list of possibilities. Okay, let's hit pause and switch gears. Remember that other path? What happens if you don't have an answer key? What if you've just got a massive amount of data and you're hoping the machine can find some interesting patterns all by itself? Well, this is where we get into the really cool world of unsupervised learning. The most popular kind of unsupervised learning is called clustering. And honestly, the name says it all. The goal here is to let the algorithm play detective. It sifts through all your data points and starts grouping, or clustering, the ones that are similar to each other. It finds these natural little groups all on its own, without any help from you.
So when is this useful? Oh, it's incredibly powerful. Imagine you run an online store. You could use clustering on your customer data and discover groups you never knew existed. Maybe you'd find a weekend shoppers group or a high-end electronics group. It's a fantastic tool for pure discovery.
Now, right about now, you might be thinking, hold on a second, putting things into groups? That sounds an awful lot like that classification thing we just talked about. And you know what? You're right to think that. They sound similar, but there is one huge critical difference between them.
And here it is. This is the key. With classification, you define the groups beforehand. You tell the machine, these are the boxes I want you to sort things into. But with clustering, the machine looks at the data and discovers the groups for you. It basically tells you what the boxes are. One is for sorting, the other is for discovery.
So there we have it. Regression, classification, and clustering. That's your foundational machine learning toolkit. You can tackle a huge range of problems with just these 3 ideas. So let's do a quick recap of how you choose.
It really just boils down to this simple thought process. First, what are you trying to do? If the answer is predict a specific number, then you need regression. If the answer is sort things into groups I already know about, you need classification. And if you're just on a mission to find new, hidden patterns in your data, then clustering is your best friend. It's that simple.
And that's really it. We've just mapped out the main roads of machine learning and filled up your new toolkit. So I guess the only question left to ask is, what are you gonna do with it? What hidden patterns in the world around you are you just a little bit more curious about now?
Thanks for watching.